Hello everyone, welcome to PB CBSE Maths. Today in this video, I am going to solve exercise 8.4 fifth main fifth question. In the fifth main fifth question, we need to show that cos A minus sin A plus 1 whole divided by cos A plus sin A minus 1 is equals to cosec A plus cot A. To show this, it is also given that we should use the identity cosec square A is equals to 1 plus cot square A. So let's try to modify this left hand side into cosec square A and cot square A. So to get cot, we should divide this cos by sin, and also to get cosec, we should divide this 1 by sin. So let's divide each and every term of this left hand side by sin A. Then we have cos A by sin A minus sin A by sin A plus 1 by sin A whole divided by cos A by sin A plus sin A by sin A minus 1 by sin A. Further, we know that in this numerator part, this sin A get cancelled, and in the denominator part also we can cancel this sin A and sin A. Then we have here cos A by sin A, which is equals to cot A minus, since sin A get cancelled, then we are left with only 1 plus that 1 by sin A is equals to cosec A whole divided by, here also cos A by sin A is equals to cot A plus, since sin and sin get cancels here, we are left with only 1 minus 1 by sin A is equals to cosec A. Then further, let's simplify this one. We can modify this numerator part as cot A. Let's factor out minus from these two terms. Then we have cot A minus 1 minus we have cosec A. In the denominator part, let's factor out this plus in these two terms. Then we have cot A plus we have 1 minus cosec A. Now let's consider it as one term and these two terms as one term, same in the denominator. Now let's multiply and divide this expression by cot A minus 1 minus of cosec A. So I am going to multiply and divide this numerator part. Then we have cot A minus of 1 minus cosec A whole divided by cot A minus of 1 minus cosec A. Now let's consider it as A, and here we have minus, and let's consider this entire expression as B. In the same way, here also let's consider this part as A, just like this, and here we have minus sign, and this entire part as, let's consider this entire part as B. So this numerator part is in the form of A minus B into A minus B, which is equals to a minus b whole square, that in the form of a minus b whole square identity. And this denominator part, let's consider it as a plus, let's consider this entire expression as b. So a plus b into bracket, here we have a minus this part as b, a plus b into bracket a minus b, which is equals to a square minus b square. We know that this a minus b whole square, let's write that a minus b whole square, a minus b whole square is equals a square plus b square minus 2ab, and this a plus b into bracket a minus b is equals to a square minus b square. So let's write this numerator part and this denominator part with respect to these two algebraic identities. Then we can write this numerator part as a plus b, a minus b into a minus b, that is a minus b whole square. So I'm going to write that numerator part as cot a minus of 1 minus cosec a whole square, that is a minus b whole square whole divided by, since it is in the form of a plus b into bracket a minus b, which is equals to a square minus b square, we can write this denominator part as cot square a minus of 1 minus cosec a whole square, that is a square minus b square. Further, let's simplify this one. Simplification gives us, since it is in the form of a minus b whole square, we can expanding this with respect to that algebraic identity, we can write cot square a plus 1 minus cosec a whole square, that is a square plus b square minus 2 into a into b, that is cot a into 1 minus cosec a. This is the expandation form of this numerator part whole divided by this one. Let's keep this cot square a as it is minus into bracket, let's expand this 1 minus cosec a whole square. Again, it is in the form of a minus b whole square. Expanding this with respect to that a minus b whole square, we can write it as 1 square plus cosec square a minus 2 into 1 into cosec a. Further, let's expand this numerator part also, which gives us, let's keep this cot square a first term as it is, plus again this term is in the form of a minus b whole square, so just expand it just like this. So expanding it, we get 1 square plus cosec square a minus 2 into 1 into cosec a. Then this term, that is minus into plus, gives us minus 2 cot a into bracket 1 minus cosec a whole divided by, keep this cot square a as it is, minus in bracket the value of 1 square is 1 plus cosec square A minus 2 into 1 gives us 2. 2 into cosec A gives us 2 times of cosec A. Further simplification gives us cot square A plus 1 plus cosec square A minus 2 into 1 gives us 2. 2 into cosec A gives us minus 2 cosec A. Then minus into plus gives us minus. Then 2 cot A into 1 gives us 2 cot A. Minus into minus gives us plus. 2 cot A into cosec A gives us 2 cot A into cosec A whole divided by, let's write this, cot square A, here also let's write A, then minus into plus 1 gives us minus 1, minus into plus cosec square A gives us minus cosec square A, minus into minus 2 cosec A gives us plus 2 cosec A. Now it is given that cosec square A is equals to 1 plus cot square A. Then cot square A is equals to cosec square A minus 1. So let's replace this cot square A by cosec square A minus 1 in the expression to further simplify this problem. Then by rewriting this cot square A by cosec square A minus 1, we can have cosec square A minus 1. Then let's write this plus 1. Now write this plus cosec square A. Then I am going to write this plus 2 cot A into cosec A. That is, I am rearranging these terms. So I am writing this term. Then let's write these two remaining terms as it is, which is minus 2 cosec A minus 2 cot A whole divided by, again here we have cot square A. Instead of writing this cot square A, let's write cosec square A minus 1. Then let's write this minus 1 as it is. Then minus cosec square A plus 2 cosec A. Further simplification gives us, here we can cancel this minus 1 and plus 1. Then we are left with cosec square A and cosec square A, that is 2 times of cosec square A. Then let's write this plus 2 cot A into cosec A. Then write that minus 2 cosec A minus 2 cot A whole divided by, here we can cancel this minus cosec square A and plus cosec square A. Then minus 1 gives us minus 2 plus this remaining 2 cosec A. Further simplification gives us, in these two terms, in the first term and in the second term, we can take common 2 cosec. So let's factor out that 2 cosec A. Then in the first term we are left with cosec A plus in the second term we are left with only cot A. Then in the third term and in the last term, let's factor out minus 2. Then we have cosec A plus cot A whole divided by, here by factoring out this minus 2 we are only left with cosec A, and here we are only left with plus cot A. Minus 2 into plus gives us minus 2, then this cot A whole divided by, here in these two terms let's take minus 2 common, then we are left with 1 plus cosec A. Then by rearranging these two terms we can write 2 cosec A minus 2 into bracket cosec A plus cot A whole divided by, we have minus 2 into bracket 1 plus cosec A. Now again in this part we can factor out minus 2. Let's factor out that. If we factor out minus 2, then we are left with cosec A plus 1 into bracket cosec A plus cot A whole divided by, we have minus 2 into bracket 1 plus cosec A. Now we know that this cosec A plus 1 or 1 plus cosec A both are same, so we can cancel these two terms, and also we can cancel this minus 2 and minus 2. At last we are left with cosec A plus cot A. This is the solution. I hope you all got this solution. Thank you for watching the video.